Guys, welcome back. In this video, we will be discussing how to check whether a given number is power of 2 or not. Let me quickly take some input and output. So if I just take the values like 1, 2, 4, 8 and 1024, all these numbers are power of 2. So I need to return the output as the value true. For example, if I give a number which is not a power of 2, like 5, 9, 100, I need to get the output as a value false. So let's quickly get into the solution. Before that, let me comment this input and output. So the first step would be scanning a number from the user. So let me just take a variable called number, initialize to the value int of input, the value given by the user. So next step would be checking the given number is a power of 2 or not. So here comes the logic. So for this logic, I'll be taking a variable called temporary, initialize with the value 1. So what I'll be doing is I'll be iterating a loop such that my temporary variable is less than or equals to my number. If my temporary value is equals to my number, I could simply print the value, or let me just take a variable called flag which is initialized with the value false. This flag variable indicates whether a given number is power of 2 or not. So when my temporary variable value equals to the number, so then I'll be making my flag value to true, and I'll be breaking from this if condition and from the while loop as well. If my temporary value is not equal to num, then I'll be multiplying my temporary value with the value to each and every time. If I just take the value of temporary as the value 8, so initially my temp value would be 1 and my flag value is false. Now if you observe 1 less than or equals to 8, condition true, but 1 is not equal to 8. So you multiply the temporary value with 2. So 1 multiplied by 2, again 2 less than 8, condition fail. So 2 multiplied by 2, it's 4, 4 less than 8, 4 not equals to num, and 4 multiplied by 2, the value is 8. So if you observe here, 8 again less than or equals to 8 and 8 equal to 8 here. So then you make your flag value to true. So my updated flag value would be the value true. So after exiting from the while loop, just simply print the value of flag. This is the very easiest approach. Each and every time you multiply the number with the value 2. The optimized approach, the time complexity would be order of log n. So let me quickly save the code and run. If I give the value 1024, the output should be true. If I just take some other number, let me just take 64. Yes, it is also a power of 2, right? Let me just take the value 9 or 100. Okay, it is a value false because it is power of 10, not power of 2. So this is the very easiest and basic approach. Instead of going with this while loop and using flag and temporary variable, there is a single line code where we could check a given number is power of 2 or not. Before discussing that approach, let me discuss few points regarding bitwise operators. When it comes to bitwise operators, there are bitwise AND or XOR, left shift as well as right shift. Here we'll be using the first bitwise operator, bitwise AND. Now if you observe, if I write the value of 4 in binary, the value would be 100. So if I just decrement the value of 4 by 1, the value would be 3. And if you write this value in binary, the value would be 011. Now if you observe here, every number which is a power of 2, we having only single one in the leftmost place. Similarly, if I just take the value 16, I'll be having 1 followed by 4 zeros. So similarly, if I just take the value 15, I'll be having 4 ones. I could make a 0 before. If you observe here, 4 bitwise and 3. When you make 4 bitwise and 3, the output would be 0. So if you observe here, 100 and 011. 0 bitwise and 1 would be 0. Again 01 is 0. 1 and 0 also the same 0. So when you convert that 000 into decimal, the value would be 0. Let's try to check that in the Python shell. 4 bitwise and 3. It's the value 0. 16 bitwise and 15. Yes, the same again. 1024 bitwise and 1023 again the same. So this could be our logic. So before writing that statement, let me comment these lines of code here. This could be the very easiest approach. Let me also just take a variable called flag1, initialize with the value false. Now I'll be checking the condition here. If number bitwise and number minus 1 double equals 0, then I could make my flag1 to the value true and you could print the value of flag1. So let me save the code now and run once again by giving the value 1024. The output should be true and true for the first and second. Let me also give the value 100 and cross check. It should be the value false for both of the cases. Yes. So these are the two different approaches. But if you observe, if I give the value 0, 0 is not a power of 2. So I'll need to get the output as false. So in the first thing I was getting the value as false, but in the second case I was getting the value as true. So what could we do is just write logical and our number should be greater than 0. So before writing after that, let me write this first. Logical and number minus 1 should be equals to 0. So let me save the code now. Let me run by giving the value 0. It should return 2 false. So these are the two different approaches. Apart from these two approaches, there is some other approach by using logarithms as well. If I just take logarithm of 2 by passing some value to it, if this value returned is an integer value, then I could say that the given number is a power of 2. In place of 2, if I just take the value x, so if I want to check whether a given number is a power of some x, so when this value gets to be an integer value, then this is said to be the power of x. So for this thing, if we check in Python, let me write that by using log2, let me just import that from math module. From math, import the value of log2. So here log2 of the value 8 would return the value 3.0, and similarly log2 of 1024 would be the value 10. So it is 2 power 10 and it is 2 power 3. If you observe, both the values are having an integer value as well as some decimal point which is 0 here, so which is 0 here as well. But here in observe, if you observe here, logarithm is returning some float value. So if I want to check the type of log2 of 1024, it says as class float. So I want this to be an integer. For using that as an integer, I'll be using two other things from the math module called ceil as well as floor. So before discussing what is ceil and floor, let me conclude 2 points about that. Ceil would be, or I could say, ceil of x. This returns the largest integer. This returns the largest integer which is just greater than the value x, greater than or equals to x. Similarly, floor of x would return the smallest integer which is less than or equals to the value x. Ceil and floor returns an integer value. Now let me use ceil first. So if I give ceil of 2.34, the value would be 3 because next greatest integer is the value 3. So the value is 3 here. It also works for negative numbers as well. If I give ceil of minus 2.34, it returns the value minus 2. After minus 2 itself, we'll be getting the value like minus 2.1, minus 2.2, and minus 2.3, so on. So minus 2 would be the greatest integer which is just greater than minus 2.34. So this is the thing. So if I just give ceil of 3.000, it is giving me the value 3. Yes. So in that case, we'll be checking this value log2 of the number that should be equals to floor of the number. Before that, let me discuss examples regarding floor as well. So if I just take the value 2.345, it returns the value 2. This is the smallest integer which is less than or equals to this value. All right. It also works for negative numbers like minus 2.34 would return the value minus 3. So if I give floor of 3.00 something, returns the value 3. So now I could check log2 of, so before log2, let me just take seal log2 of the number. If I just take 1024, this should be equals to floor of log2 of number would be 1024 here. So it is returning the value true. So that statement we could conclude here. Before writing that, let me comment these two lines regarding seal as well as floor. So let me just take other variable called flag2 initialize with the value false. Next, we could check if seal of log2 of the number, it is equals to floor of log2 of the number. That's the thing. Just simply make your flag2 to true, and you could print at last the value of flag2. Save the code, run the code, give the value like 1024. Sorry, okay, we didn't use seal, floor as well as log2. So first we need to import that from the math. So let me import that from the math module. From math, import log2, seal as well as floor. Save the code, run again. You should not throw any error now. Yes, we're getting all the value as true. Similarly, if you observe, if I just give the value 100, the three values are false. So these are the different approaches we could check. So the first approach by using a while loop. The second approach is the very easiest approach when compared to the first and third. The third one also we just take the help of seal, log and floor functions. But in the second approach, if we observe just a variable and we are performing some operations on the given input variable itself. So there is no loops and there is no nothing. So this could be the very much optimized approach. These are the different ways for checking whether a given number is true or not. I suggest using the second approach would be the very much optimized. That's all for this video, guys. Thank you for watching. See you guys in the next one.